Hello, everyone. Welcome to our Succeed with Variable Rate webinar. Thanks for taking the time to join us. My name is Chris Hawkins. I'm the Sales and Communications Manager with CropPro Consulting. I'll be your moderator for this session. Our plan is to be as efficient as possible with the time that you've given us. So we've pre-recorded each of our presentations. They should take about 40 minutes to go through. After that, we'll transition into a live Q&A session where we can answer any questions that you may have. You'll notice each of your microphones have been muted. That way we can stay focused and on track. We certainly do encourage your questions though. So as you think of them, simply press the Q&A button on the bottom of your screen and type your question into the submenu that pops up. I'll be sure to ask your questions on your behalf at the end of the presentations. For those of you not familiar with CropPro Consulting, we are a fully independent agronomy company and we started business in 2003. In 2008, we started doing variable rate using our SWATMAPS technology. Today, we have 13 sampling trucks, 6 mapping trucks, and 25 staff throughout the province. Our client base continues to grow because people are starting to realize that we do have the expertise to help them succeed with variable rate. This is validated by the fact that we have over 95% client acre retention rate year after year. So we're proud to share some of that expertise with you today. But before we do that, we're going to ask Carrie DeGoyer to spend time explaining to you what SWATMAPS are and why we need them. Carrie DeGoyer is our operations manager and also our senior precision agronomist. She's a professional agrologist and a certified crop advisor. She grew up on a mixed farm just outside of Sheeho and currently makes her home in Melfort, Saskatchewan. She got her university degree in agriculture from the University of Saskatchewan, where she focused on crop science. She joined CropPro in 2014, and part of her role includes providing precision agronomy service to Melfort and northern Saskatchewan. She truly is a proven SWATMAPS agronomy expert. She's going to spend about 10 minutes going through what SWATMAPS are, and then I'll introduce our main speakers. So without any further delay, please welcome Carrie DeGoyer.
Thank you, Chris, for the introduction. Welcome, everyone. As he said, if you have any questions as we're going along, please put them in the Q&A or wait till we're done and ask them live. So what we're doing is we are mapping soil potential, and the map that we build becomes the starting point for everything that we do next. It's the basis for our soil testing locations and also our fertilizer recommendations. So in essence, what we're doing is we're capturing soil, water, and topography attributes from your field. So take what you're seeing in your field and putting it in a zone map. So taking what we're seeing in your field and putting it in a digital format so that we can manage each area appropriately. So along the bottom, I threw up some example SWAT zone maps overlaid on 3D models of some fields that we work with. And the 3D model is exaggerated just to really highlight and emphasize where the hilltops are versus the depressions. And if you look at our legend, each color on the zone map is its own management zone. So right off the bat, you can see all the high and dry hilltop areas of the field are their own zone. They're managed differently than the rest of the field. And then on the other end of the spectrum, all the water collecting depressions are their own zone as well. So you kind of see where we're going with this. I threw up a field here that was summer followed. And if we still summer followed all our fields, this is very typical of what we would see. You see this hilltop in the foreground and then some hills in the background. They're all drier. They're usually lighter textured soil, definitely lighter colored soil, and also usually a thinner topsoil depth. And then you compare that to as you go into the mid slopes and then these depressions, the depressions are wetter, usually higher organic matter levels, and a thicker topsoil depth. So this is what we would see in our fields, or this is what we do see in our fields. We want to get a map of this because the crop up on this hilltop versus this depression are going to respond to fertilizer differently and yield differently. So we want to make a map of that. How do we do that? We go out and we physically map your fields with our mapping trucks. So I threw up a picture of one of our mapping truck setups. You can see this contraption here. This is a SWAT box. It's got an EM38 in it, and it's measuring electrical conductivity. And then we've also got this RTK base station set up. And as the truck is driving around the field, it's capturing elevation and topography data. So those two layers put together, the EC layer and the elevation topography layer, they capture a number of things. One of the things they capture is soil texture differences. That's what the EC layer is doing. It's going to delineate where the lighter textured soils are versus the heavier textured soils so that we can manage them separately. It's also going to capture salinity. Not every field has salinity, but if you do have salinity, it's going to really pinpoint where that is so that we can manage that area separately from the rest of the fields. A lot of fields actually have light salinity that maybe isn't particularly visible to the naked eye, but the EC layer will capture that as well. And then, of course, for capturing water runs, depressions, and hilltops. So if you think of your own fields as you're combining them, they're not yielding the same corner to corner. You have variability. Now, what causes that variability? It can be 100 different things. It can be man-made. It could be related to insect pressure. It could be related to weed pressure, or it could be related to some fertility-based factors in the field. Things like soil. If you think of your own field, you likely have different topsoil depths and organic matter levels in different areas of the field. If you think of water, where is it dry versus where is it wet? Water's always running somewhere. And this is going to have a big impact on how the crop yields and how the crop is going to respond to fertilizer in those different areas. And then, of course, topography. So threw up another example, SWAT zone map overlaid on a 3D model again. And as I said before, the 3D model is over exaggerated just to really accentuate where the hills and depressions are. But looks like there's mountains in this field. There's not. But right away, you can see that all these high and dry parts of the field are zone 1 and 2. And then as you go into the mid slopes and the more water collecting areas of the field, you get into the zone 10s. So this map is really capturing the fertility-based variability factors in your field, the different soil types and textures and depths, and where the water is going. One last step before we choose a SWAT zone map is we go out and ground truth it. And what that just means is the agronomists go out and make sure that the map we chose matches the field perfectly. So as the agronomist goes out in this field and they're driving around in a zone 1 area, when they're out in the field, it better be the highest and driest part of the field. On the other end of the spectrum, this is that same example field. This particular field has very high salinity. So when they're ground truthing a field like this, all the very highly saline spots need to be in a zone 10 so that we can manage them completely separately from the rest of the field. Like I said, not all fields have salinity. So if you have a field that doesn't have salinity or fields that don't have salinity, the zone 10 is always the most water collecting area of the field. So it's the areas of the field where water runs to after a big rainstorm. So we've chosen a map. The next step is we go out and soil test it. And our zone maps are 10 zones, but we sample to 5 zones. And this gives us a really, really good idea of what's going on in the field, in all areas of the field. If you compare that to composite soil testing, with composite soil testing, you're collecting soil from the mid-slope areas of the field, putting them in a bag, sending them off to the lab. That's a 1-zone soil sampling procedure. We sample to 5 zones. So with the ones, if the sampling truck is in sampling this field, they go to all the 1 areas, collect cores from there. and put that soil in a bag to go to the lab. And all the soil from this zone should be very similar. They should all be the lightest textured soils in the field, the driest soil in the field. So it makes sense that they're grouped together. And then on the other end of the spectrum, the 5s, this is the most wet, most saline parts of the field. And then we sample 3 zones in between. So these points are all GPS referenced, so we go to them every single year. So we also get a really good picture of what goes on year to year. So how are SWAT maps different? This is a map based on soil properties, and this is really important because we are applying inputs to the soil. So it makes sense that we start with what's going on in the soil. And our SWAT maps can give you an answer to why your crop is yielding the way it is in certain parts of the field. If you were to compare that to making zones from yield or satellite imagery, those don't give you the whys. They just tell you what the crop yielded at that certain point in time. And the big problem with them is that they can group areas together that shouldn't be grouped together. So what I mean by that is you might have a medium yielding hilltop, and you might also have a medium yielding depression. So the satellite image is grouping those 2 areas together. They're both medium yielding, but the soil properties are nothing alike. The crop in those areas are going to respond to fertilizer differently. So that's why we need to use SWAT maps to make a zone map, because we're applying inputs to the soil. It matches the field so that we can manage each area appropriately. And the key point, I guess, is different areas of the field, the crop is going to respond to fertilizer differently. So if we're taking your existing fertilizer budget, you're already spending the money on the fertilizer, we're better able to put that fertilizer where the crop is going to respond more, so where you're going to get the optimum return. So this is my last slide. Not all variable rate is the same. I went through how we map your soil potential and soil test the field. This becomes the basis for what happens next. I didn't go through what happens next. That's where the agronomists in the next section will go through some specific strategies they use in the area. The last point is just saying that everybody's fields and soil test results are different. So what is the value of SWAT maps? We could give specific examples of 10 different ways we can provide value. And those will have a cumulative effect. Some of the strategies, you might put more weight on certain fields than others, but both in the long term and the short term, you will see value to using SWAT maps. And I think the key point is that we have a really high client retention rate year over year. If our clients felt like we weren't providing value to them with our fertilizer recommendations and agronomy recommendations, they could leave us. We don't make anyone sign multi-year contracts or anything like that. So our clients are having success with variable rates because we are starting with a really good base. We're starting with a map that captures soil potential.
Thanks, Carrie. Now it's time to hear from Brandon and Matthias, our local SWATMAPS agronomy experts. Brandon Smith is a senior precision agronomist here at Crop Pro. He's also a professional agrologist and grew up in the Rose Valley area. Brandon spent a lot of his summers working for a local area farmer who just now happens to be one of our clients. So that's a real good sign. But Brandon makes his home in Humboldt, and he got his university degree from the U of S, where he studied agriculture and focused on agronomy. Brandon also took a couple of years university at Dalhousie in Halifax, and he studied biochemistry and molecular biology while he was there. Smart guy. So Brandon joined us in 2015. Matthias Kroijmans is also a precision agronomist, and he's an articling agrologist as well. So Matthias came from a seed grain farm in Bow Island, Alberta, and he studied at the University of Saskatchewan as well, got his agriculture degree, and he too focused on agronomy. Matthias joined our team here at Crop Pro in the spring of 2020, and we're certainly glad to have him on board. So these two fellows work together to provide precision agronomy services to central Saskatchewan farmers. A lot of these farmers in this region have a wide variety of agronomic challenges, often caused by soil variability. So today we're going to have them tell us how they successfully use SWAT technology to help their clients overcome these challenges. They'll be highlighting fields from the Wadena area, so we want to make sure to thank Corey Fair for permitting us to discuss some of his fields. Thank you very much, Corey. So without any further delay, let's hear from Brandon and Matthias.
Thanks, Chris. Today I'm going to share with you some of the strategies I use to help my clients succeed with SWATMAPS. So first, I thought we'd go through what the goal of variable rate is and some of the fundamentals, and that we want to apply the right rate in the right zone. So Carrie's already gone through step one, that you need to get the zone map right. With SWATMAPS, we're grouping areas of the field together that have similar fertilizer response characteristics. Step two is that you need to get the fertilizer rates right, and that's what I'm going to go through today. Applying more nutrients where your ROI is the highest. Looking at a few of our value propositions, so a high ROI on applied nutrients, you're already spending money on the fertilizer. Let's take that budget and put the fertilizer where the crop is going to respond to it the best. Some of the factors that we need to look at is end mineralization, sulfur response, phosphorus response, and I'll go through these in details later on. We want to even out crop staging and maturity, which will help with fungicide staging and harvest maturity. We want to delineate saline areas. So find those pockets in your field that have salinity so that we're able to cut the fertilizer back. And with this, you're getting expert, non-biased agronomic advice. We don't sell any fertilizer or inputs, so all of our recommendations are based on what we feel is best for the client. This chart here is a good way of looking at how we can manage and how we do manage our zones. So you have yield potential and fertilizer response probability. You could have a zone in the field that's got low yield potential and low fertilizer response, such as a saline depression. In this area, we would cut back fertilizer because it's got a low fertilizer response and low yield potential. So you're not sacrificing any yield and you're saving money by cutting fertilizer back. You might have an area that's got a high yield potential and high fertilizer response. So in this area, we're going to apply more fertilizer, which in turn will hopefully grow more bushels. There's also areas in the field that could have an average yield potential and a low fertilizer response. So an example of this might be a depression, a non-saline depression that's got high organic matter, it's got lots of nutrients, so the response to fertilizer is low, but it still yields well. In this area, we would cut back fertilizer without hopefully sacrificing any yield. Looking at some different topsoil depths, the differences we see in the field. So this chart on the left here is showing that through time and erosion, topsoil has blown off of the top of the hill and deposited into these depressions. And what you're left with is a thin topsoil on the hills and a thick topsoil in the depressions. These are a couple cores that I took from a field in Wadena. So the zone 1 hill, thin topsoil. This zone 8 depression, it's got this thick topsoil, 14 inches of beautiful black dirt. These two areas in the field are going to respond to fertilizer much differently. Now looking at this picture, we're sitting in a depression here. Pretend we're out here pre-harvest timing for wheat. You can see here on these other parts of the field, the wheat's ready to go. And we're waiting on these green depressions, these lodge green depressions. So the question I ask is increasing nitrogen rates always a benefit, right? As yield goals go up, we want to keep pushing fertilizer rates. And when you're flat rating it, there becomes parts of these fields that the nitrogen rates are too high. They got high organic matter here Nitrogen is mobile, so it's moving and pooling into areas of the field. And this is causing delayed harvest issues with lodging, poor looking samples. There's an increased risk of frost. So the thought process is, can we take fertilizer from this area of the field and allocate it to different parts of the field? And mineralization potential. So by end mineralization, what I'm talking about is the soil's ability to release plant available nitrogen throughout the year. And soil organic matter, as it increases, and mineralization potential increases. So there's a relationship between the two. So looking at this picture here and the end mineralization potential that I just talked about, you got an eroded hilltop, 2% organic matter, thin topsoil. As you move down the landscape, depression could have as high as 6% organic matter. Nitrogen is also mobile, so we know that it's also moving throughout the field. It's mobile in the soil. This hilltop might pump out, say, 10 pounds of nitrogen, whereas that depression, that 6% organic matter, could release anywhere from 30 to 60 pounds. As I just showed you, there's a relationship between organic matter and end mineralization, but moisture also plays a factor in end mineralization. We know that in drier years, the end mineralization is lower than in wetter years. Well, there's also moisture differences within a field on any given year. So not only is this depression higher in organic matter, it's also wetter, giving it more potential to release nitrogen. Going back to that same chart that I showed you a few slides ago, looking at the yield potential and how we would use this strategy for nitrogen. So a zone 10, low yield potential, low fertilizer response. We're going to cut fertilizer back in this area. Zone 1, eroded hill that I just showed you. It's got a low yield potential, but a pretty medium fertilizer response. If it's wet, that yield potential could move up. This is what I like to call the gambling areas of the field, where we're trying to predict whether it's going to be wet or not, if it's going to pay to put fertilizer there. Something like a zone 4 to 5 mid-slope, it's got high yield potential, high fertilizer response. This is where we want to be putting high rates of fertilizer on any given year because it's got that high yield potential. Looking at a toe slope, so a depression, average yield potential, low fertilizer response, so it's a zone 9. Like I said, it's got high organic matter. It's fertile already. It's not going to have a real strong response to fertilizer. So in an area like this, it's actually better to cut back the fertilizer rates to reduce lodging and maturity differences while still obtaining good yields. So I'm going to go through an example field from Wadena, Saskatchewan. It'll be a real life example of what we did on this field last year. Looking at the SWAT map here in 3D, there's some hills and some light textured soils that go through this field. There's a bit of a ridge that goes through here. It's also got some very saline zone 10s that I'll show you on the soil test here. So we applied anhydrous in the fall of 2019. This is the recommendation or the report that I made for the client. I've circled here the soil test N from fall of 2019. You can see it's pretty consistent throughout the field, other than in that zone 9 to 10 saline area of the field where it's quite high. The organic matter, it doesn't change a whole heck of a lot, but it does have that trend that we often see where it's lower on the tops of the hills and it increases as we move down the landscape. Also paying close attention to the salinity in this field. So anything over 3 would be considered very high. So that zone 9 and 10 have very high salinity numbers. We had a yield goal of 62 bushels. And this is the NH3 report, or the rates that we selected. This is an actual N. So you can see on the tops of the hills, we're still putting a fairly high rate. It doesn't have as much potential as some of the areas in the field, but we know that if it does rain, we can get a pretty good response to fertilizer here. Lower organic matter, so we know that we're going to have to put fairly high rates to get our yield goal in that zone. And as we move down, started increasing the nitrogen rates to the best part of the field, which is the zone 5s. That's where we put the highest rate. And as we start to get into the zone 6s to 8s, these zones get wetter, they got higher organic matter, they're going to release more nitrogen. Keeping maturity and lodging in mind, we started cutting back the rates. And then finally in the zone 10 here, putting just 30 pounds of nitrogen. There's not much yield potential here at all. So we're cutting it back as much as we can with NH3 for an average of 115 pounds. So that's what we decided to do for nitrogen rates on the field. Looking at sulfur, it's also mobile and follows very similar trends to nitrogen. It's also mineralized. So this is often the trend that we see, probably 90% of the time. The hills will have very low sulfur numbers. And as sulfur moves through the soil and becomes mineralized, we see loads of sulfur in the depressions. Keeping in mind, sulfur plays a role in drought stress. So the areas of the field that are drier typically also have the lowest sulfur numbers. So we need to be making sure that we're addressing our sulfur requirements in those parts of the field. These are some pictures and soil test information from our Precision Ag Research site in Nacum. I always like showing these differences in topsoil depth. It's always cool to see the soil profile and how much it changes within the field. This is actually a fairly flat field. It's got a gentle slope to it, but it's not real hilly. This zone 1, this thin topsoil, as you see, once you get to the mid slopes of zone 5, that topsoil begins to get thicker. And then this zone 10, it's actually a non-saline zone 10. You get this beautiful black dirt here, thick topsoil. These are the soil tests for sulfur in that field. See, it's very low sulfur levels from zone 1 to 8, and then zone 10s are loaded with sulfur. So the question I ask is, does sulfur respond the same across the entire field? This is a 0 sulfur strip. There was 0 sulfur applied on this canola in this strip. Look in this zone 7 to 9, like I said, it's got that thick topsoil, it's higher in organic matter. The soil tests actually showed that it was still quite low in sulfur, but the soil is releasing more sulfur. It's also moving throughout the soil into these areas and collecting because it's in a low spot. Beautiful canola with 0 sulfur. You go on top of a hill, it's got that thinner topsoil, it's lower in organic matter. So the sulfur is moving and leaching from areas, or this area. You got severe sulfur deficiency, cupping of the leaves, you can see some purpling. Sulfur definitely responds different in different parts of the field. Phosphorus. This is a trend that we often see, but it's not always the case. It just kind of showed it as an example. Phosphorus isn't mobile in the soil, but as soil is eroded over time, it's taken nutrients with it. Get this eroded hilltop. It's got low phos levels, 5 ppm. As you move down, it becomes increasing in that, especially if you start to get to a saline area of the field where you've been flat rating phosphorus, not much crop growing there, so your removal rates are low. You'll often see pretty high phosphorus levels there. Potassium, again, similar trend to what we see with phosphorus, typically lower on the hills, especially if it's really sandy. One anomaly to this is as you move further northeast of here and you start to get some peat pockets, these peat depressions will actually be quite low in potassium. But this is a pretty common trend to what we might see. So this is the drill report, the VR drill report that we did in the spring of 2020. As I mentioned, we've already put our nitrogen down. It was banded in the fall, so we're just looking at putting down our phosphorus and sulfur in this case. Looking at phosphorus first, these tests, you can see actually the zone 1 and 2 in this field, quite high in phosphorus. Anything under 15 ppm would be considered low. So it's kind of a lighter textured soil in the zone 1s to 2s. So there's not as much calcium and magnesium in that part of the field tying the phos up. So that's why we see that higher number on the soil test here. Cut it back a little bit in the zone 1s, and then we're kind of maxing things out in the zone 3s to 8s for what we're comfortable seed safety wise, and cutting it back in the zone 10s where there's not a lot of yield potential. Looking at sulfur, again, this is the common trend that we see. Really low sulfur levels on the zone 1s to 4, and then high sulfur in the remaining parts of the field. So we're loading sulfur on these hills, 115 pounds. So this is in pounds of product. And then as we're moving down the landscape, we're cutting these rates back all the way down to 30 pounds in the saline areas. So this is what we did on the field, and hopefully shows you some of the strategies that we use for our VR fertility. And next, Matthias is going to talk about VR seed.
Thanks, Brandon. So I'll start right away with the benefits associated with VR seed. What we are striving for with variable seeding is even crop maturity. And in order to have even maturity, we need to have an even plant stand across all areas in the field. In doing so, we can limit excess branching or tillering, which can be a driving factor in delaying maturity. After the crop has been planted, the main influence on the plant stand is seed or plant mortality. And a few factors that can result in mortality are higher insect pressure, too much or not enough moisture, salinity, and the soil microclimate. And when I say microclimate, what I'm referring to is higher susceptibility to wind damage on exposed hilltops and higher susceptibility to frost damage in depressions. A few other benefits of variable rate seeding include by maintaining an adequate plant stand across the field, we can ensure the crop remains competitive in the marginal areas, therefore reducing the chance of weed outbreaks. Another is that when we achieve even maturity, timing a fungicide or pre-harvest application can be much easier to do. This is a good example comparing two fields, one that had variable rate seed and fertilizer, and another that just had a uniform seed and fertilizer rate. On the left, we can see that the crop stage in zone 2 and zone 8 are very similar, right around the 25 to 50% head emergence stage. As for the group of pictures on the right, this is not the case. The plants in what would likely be a zone 8 are much farther behind, with only the awns being visible, whereas the plants in what would likely be a zone 2 are at about 25% head emergence. These pictures help show how much easier it is to time a field that has even plant maturity. In this case, the agronomist was staging the field for a Fusarium head blight fungicide, and as we know, the optimal window for this is quite short. And if you fast forward these fields a bit to when they are starting to ripen, chances are we would have to wait much longer to desiccate or swath the flat rate field, because we need to wait on those plants to mature. So the typical seeding rate pattern that we follow is the mid-slope areas are seeded at a rate just below the field average. Then we increase the hilltops slightly by about 10%, and then we increase the rate even more for the water collecting or saline depressions. These seeding rate adjustments are just generalizations and are open to change for each client. The seeding rate for each zone will always depend on what the agronomist sees during the variable rate checks, because no two fields are alike. And sometimes zones 1 and 2 aren't always an eroded hilltop, and sometimes salinity can extend beyond zones 9 and 10. Now I'll touch on some plant stand data that we have collected over the years, and I'll start with this graph for canola stands in 2012. These plant stand counts were done before we started using SWATMAPS to vary seeding rates. There is an obvious bell-shaped curve, with the mid-slope having the higher plant count and the hilltops and depressions dropping off quite a bit, with the depression seeing the largest decline in plant stand. Overall, there was a change of about 2 plants per square foot across the zones. And 8 years later, we've gotten our plant stand counts looking pretty even by refining our recommended seeding rates to match expected mortality in each zone. The plant stands in zones 1 to 8 are quite impressive, and there is only a slight decline in zones 9 and 10. But overall, the average plant change across the field was only 1 plant per square foot. I've also included the typical seeding rates in pounds per acre on the right, just to show the typical trend. This is a data for wheat acres in 2020, and similar to the canola, there is very little change in the plant stands across the zones. Overall, there was a change of about 3 plants per square foot across the zones. And to summarize these graphs, I would say we are quite confident in the seeding rates we are recommending for our clients, and we can back them up with knowledge of factors that are influencing each zone in the field. This is a cool illustration of a seed prescription map for a wheat field in the Quill Lake area, and it highlights what I've been explaining in the past slides, where we have the lowest seeding rate in the mid-slope area of the field, which in this case is 135 pounds per acre. Then those green areas represent the hilltops of the field, and we've increased the rate slightly to 150 pounds per acre. And lastly, the purple areas, which represent the saline depressions, were seeded at 165 pounds per acre. And I'll mention as well that for this field, the average seeding rate came out to roughly 141 pounds per acre. I'll finish off with the accompanying plant stand report for the field I just showed, and each client receives a plant stand report after the agronomist completes the first variable rate check for their farm. In regards to this report, the first thing I want to point out is the much stonier texture in zones 1 and 2. Yet we were still able to have an adequate plant stand and keep the crop competitive. As for zones 3 to 10, the plant stand is very even, right around that 31 plants per square foot. Generally, these plant stand reports won't include the seed mortality numbers below the zone pictures, but I've included them for the purpose of this presentation to show that this field did in fact have much higher mortality in the marginal areas of the field. And at the end of the year, we will use these plant counts, our observations from the second variable rate check, where we look at how even the field is maturing, as well as a few other agronomic factors, and then discuss with the client whether the seeding rates need to be adjusted or not.
Looking at some other ways that we can use SWATMAPS, just some examples. VR herbicides, soil applied herbicides that the rate is influenced by either organic matter or texture. Examples of this would be Edge or Authority. We can VR that based off of the soil test information that we have of the field. VR insecticide, so you might, or we often see cutworms eating just the tops of the hills, so only applying insecticide on those areas of the field. VR plant growth regulators such as Modus or Manipulator. Is the risk of lodging the same on a hilltop as it is in a depression? Typically plants will be shorter to begin with on a hilltop, so are they really going to benefit from the use of a PGR? VR fungicides. We've used SWATMAPS to variable rate an on-off fungicide prescription. You can turn it off in a saline zone 10 or a super sandy zone 1. We have used imagery for this as well. It's kind of a case-by-case example, but just some other options and other ways that we can utilize SWATMAPS. So here are two examples that we've used. So we got on the left here, coworker Brad Dunnington made a prescription for spraying Authority. Low rates on the low organic matter knolls. See, they're putting 6 gallons water on the knolls and then 10 gallons on the other parts of the field. So utilizing SWATMAPS to make sure that we're getting the right rate of herbicide down to make it work as good as possible. So Jill was scouting this field and found that there was cutworms on tops of the hills and the light areas of the field. Made an on-off prescription based off of the SWATMAP. So we're putting it on the zone 1s to 4s. This is what the prescription looked like. Purple means spray, red is no spray. So not only saving the farmer money, but also not killing beneficial insects in areas of the field that didn't have any cutworms. So two really good examples of some other ways that we've used SWATMAPS. So I figured we'd talk about the software that we use. It's called SWAT Records. Previously it was called Crop Records, but we're just in the midst of changing that name. It's a free app that us agronomists use for our field scouting. Our clients also are synced to us and they can view their maps on their phone. We also use this for all our ground truthing and soil sampling. There's a desktop version that we use to make the VR reports that I showed you today, as well as all of our recommendations for spraying and any crop records that we're doing for our clients. So why choose SWATMAPS? Hopefully today you learned a lot about what we do and how we utilize our maps to help our clients succeed, higher ROI on applied nutrients, even out crop staging and maturity, can help reduce lodging, delineate saline areas so we can cut fertilizer back in those low potential areas. We're getting expert non-biased agronomic advice from our team of agronomists, and just keeping in mind that our client retention rate is over 95%. So our clients year over year continue to work with us and keep hiring us, and we're helping them succeed with variable rate. Thank you.
So we're going to give $1,000 credit to those of you in attendance if you map at least 160 acres this spring. So if you're a brand new client to us and you've never mapped before, that's available to you. Simply just put your name and phone number. We already have your email, I believe, but put your name and phone number in the chat box, and that way we can be sure to get in contact with you and go through some finer details. That chat box just comes to us as panelists, so feel free to share it in there. Existing clients, you also have an opportunity to get the $1,000 mapping credit if you referred one of these new people to this webinar. And of course, if you're in the webinar now yourself, you simply just need to map 160 acres. And then that has to be done this spring as well. And also let us know which person you referred by using the chat box on the bottom of your screen.
Thanks, Chris. Yeah, good question. So year to year, we don't change the zone maps. We're mapping soil potential, so that's not really changing over time. You know, unless of course you did some major tile drainage or something and you were able to shrink those saline areas or something, we might go back and remap that. But in other ways, our maps stay the same. We can just manage them differently year to year. So thanks for the question.
Yeah, very good. Okay, the next question on the list is, have you done any VR micronutrients? And I'm not sure, Matthias, if you will have done any personally, but go ahead and answer that if you wish. If not, you can defer that.
I haven't worked with them a whole lot this past season, but I know Brandon and Gary have quite a bit of experience with what we've done for VR micronutrients, so maybe one of them would be better to talk about that.
Sure.
Yeah, so we have done quite a bit of this. A good opportunity comes when the client has a tank that you might use for canola seed, like a saddle tank. And when you're seeding cereals, we can start VRing the micronutrients. So maybe just putting zinc or copper on the hills, that sort of thing. So yeah, we actually have done quite a bit of that and did some research this past year on it too, on some other micronutrients. So yeah, another good question.
Yeah, you bet. So another question that comes up fairly often is regarding the zones of the map. And the question is, do we always have 10 zones when we're doing our soil maps? And maybe I'll let Carrie, you go ahead and answer that one.
Yeah, so all our zone maps are 10 zones. We don't necessarily apply 10 different rates every time. It's just, it gives us the resolution we need to do that if we feel that's necessary. So it's always 10 zones. The map doesn't change over time, but yeah, we don't always put 10 different zones though.
Okay.
Or
very
10
good.
different, sorry, 10 different rates.
Yeah, it depends on the circumstances of the field, right? Very good. Now, are we soil sampling in every one of those 10 zones? Matthias, why don't you take that one?
No, we don't sample each and every zone. So we'll group zones 1 and 2 together. We find that these ones are quite close in characteristics, or close enough. And then same for zones 3 and 4. We'll sample those together. And then 5 and 6, 7 and 8, and 9 and 10. Just helps with getting through the field. And we find that we can group these zones together. So we're close enough.
Yeah, you bet. Yeah, and it gets to be, we don't want to make it cost prohibitive, right? We want to make sure that we're making this process as affordable as possible, and we get enough good information with the 5 zones in sampling to be able to give really strong recommendations in all 10. So really good. Another question that I know I get often, well, before I ask that one, I'll ask this next question that came up on the chat. Have you compared the profitability of your zones versus current uniform practice? And can you tell us some numbers? And about the return on investment, do you usually have it in 2 years? Brandon, what do you think on that? There's quite a few questions in there, but tackle them one at a time if you wish.
Yeah. So we haven't done a ton of the checks versus, doing it flat rated. Often clients will try a couple fields and compare what we're doing to the rest of their farm. What was the other part of the question? How long is it taking? So, right. I mean, that's going to depend whether, some differences in, say your nitrogen or something, you can see differences right away. But if we're, for phosphorus or potassium or something like that, it's more of a long-term sort of difference. But it's a tough question to answer because it's so dependent on the field. Like obviously the more variable your field, the quicker we're going to see some differences. But we have started doing profitability maps just this past winter, so there'll be some more information on that as we go on, I guess. So hopefully that makes sense.
Yeah, and we're going to be having yield maps available where we can show just how much yield there is in each of the different zones. So all that work is being done in the background, and it just helps people to get a better understanding of the benefits of the process. So yeah, good job. Another question that we often get is when is the best time to do the mapping? And maybe I can answer that one for you. And we generally have 2 primary mapping seasons. One is the spring, and then one is in the fall. Now, of course, in the spring, we have a much more condensed window to work with, but we certainly do have time to map fields in the spring and get the soil sample results back in time to get recommendations and prescriptions and all the process completed before you get into the field. Mother Nature obviously has a big impact on that, but generally speaking, we're very, very good at getting the information in time. As far as the frost in the ground, which often people ask about, does that affect our data collection? Certainly it does influence the numbers, but what we're looking for is a relative change in EC. We're not necessarily concerned with the absolute value of EC. So whether the ground is frozen or not frozen is okay, because the relative changes still occur. So that means that we can still map in the early spring and we can still map in late fall and get very, very solid, accurate maps. So I don't see any other questions popping up in the Q&A. If anyone else has some, by all means, feel free to jot it in there. I don't know if either of the other panelists, can you think of some questions that maybe are common that you may want to contribute? Putting you on the spot, I know. For anyone that's still sticking around in the webinar today, we do understand that sometimes people are not comfortable with asking questions in a public forum. So that's okay. As I mentioned earlier, you can reach out to any one of us. Just leave your contact information in the chat box, and we'll certainly be able to reach out to you and have that discussion privately if you wish. I do want to highlight one other thing that we do have coming up in the summer. We don't have exact dates set, but last year we started with our Precision Ag Research site in NACM, And we do a tremendous amount of great research there in the precision agronomy arena. And we're going to be doing that again this year. So there's going to be lots of good information. So I encourage you to check back at our website at croppro.ca as we move into the summer months, and pay attention on Twitter. I know that several of our staff is active on Twitter, and you can reach out to us there as well. We will be promoting the site tours as they are announced. So, good stuff. A couple more questions coming in. Justin is asking, how do you charge for extra map applications, be it a floater or sprayer or other piece of equipment? That's a good question. Brandon, you want to go ahead?
Yeah, so it's an extra $50 a prescription charge. So yeah, that can be as the example that I used if they're doing fall anhydrous or any floater applications. So it's a $50 charge for an extra prescription.
You bet. So another question, can farmers do their own mapping on their own machines, but then get ground truthing and recommendations after that? Matthias, can they do that?
Yep. So there is ability for farmers to put what we call the SWAT box across their fields and map their fields. And then once we usually have a couple maps made, then yeah, the farmer will come out and do the ground truthing. And then from there, we work with the recommendations and work with the clients to pick what's best for their field. So.
Absolutely, yeah. There are limitations though to keep in mind when you're dealing with the autonomous SWAT box. That's what you're referring to actually, is our autonomous SWAT box. And we need to be able to access high quality elevation data in order for that process to work. So in Saskatchewan, we don't have LiDAR elevation available to us in most areas, but in rare circumstances, farmers' own RTK elevation data may work, but that would have to be verified by CropPro. Typically, the autonomous SWAT box is not very commonly used in Saskatchewan. But yeah, that possibility does exist. You can reach out to us separately if you're interested in that. We can discuss whether it's a possibility on your farm. So the next question is, have you utilized SWAT maps with direct inject systems to apply multiple AIs at once in a targeted IPM approach? Holy cow, that's pretty intense. Are you comfortable with that one, Brandon?
Yeah, you bet. So this is actually something that one of my clients and I have talked about. He just got a sprayer that has this injection kit, and I see a great fit for it, especially on his farm. He's got lots of saline zone 9s and 10s that grow basically nothing but kochia. So I mean, the idea is that we don't have to be spending expensive chemicals on the whole field. You know, we can inject some Authority or Valterra into those specific zones. So yeah, this is something that it is possible. Personally, we haven't done a lot of it yet, but yeah, definitely something that's on the radar, and I think it would be really cool to utilize.
Yeah, the future of our equipment is just only going to get better, right? Our maps have so much resolution that we can handle far more precision than the equipment can provide for us yet today, but it's coming, and the equipment manufacturers are all getting better and better, like individual nozzle control, for example, in sprayers, but that technology is working into the drills as well. And it's exciting. The future is looking very bright for making use of these maps, and it'll be very helpful as they improve. So another follow-up question. Our farm has just been LiDAR'd corner to corner. Could those zones be pulled off that instead? Well, I can tackle that one. Yeah, when we have access to LiDAR on the entire farm, we can use that data, and we can incorporate that into the production of a SWAT map. But we don't make the SWAT map just off of LiDAR. We need to have the EC as well. So we can make it work though when you have that kind of LiDAR on your farm. Okay, I think I've got to the end of the questions. It doesn't look like there's any new ones popping up. Yeah, I think we're okay. So where are we at? We're just about dead on 11 o'clock. Our goal was to finish in an hour, and I feel like we've accomplished that. But just keep in mind, for those of you that are still on this webinar, we're not rushing off. We're happy to stick around as long as you want to visit. But so if you have more questions, feel free to jot them in, but I think we're kind of winding down now. So we have a comment that says, thank you for this. Well, thank you for listening. We're glad you could join us. And there will be a couple more webinars coming up in other regions that focus on other territories. We're trying to be region specific as we do these webinars to try and help people learn how SWAT maps can apply in different areas and how different strategies can be incorporated using SWAT maps depending on the region that you live in. So thank you everyone for attending.